Subtopic number 2, which is on equilibrium of a uniform rigid body. So in this subtopic, you have to be able to state the physical meaning of cross-vector product for torque, define and apply torque, state conditions for equilibrium of a rigid body, and lastly, solve problems related to equilibrium of a uniform rigid body. So torque ataupun the Greek letter word is tau. Ni simbol dia lah. It is defined as the tendency of a force to rotate about an axis. Okay, so any tendency of an object to rotate is what we call torque. And how do we calculate that? We calculate it by using this formula here, where theta is the angle between force and r, which is the distance from the point of rotation to the point where the force is applied. So the SI unit for torque is Newton meter. It is a vector quantity. So a positive torque means the turning tendency is anti-clockwise. If it is negative, it is clockwise lah. Okay, so the turning tendency is clockwise. Next, the ability of a force to create torque and cause rotation depends on three factors. So the three factors are the magnitude of the force, the distance from the point of application. So the greater the distance, the higher the torque. And lastly, the angle at which the force is applied. So if we look at this diagram, the same force applied at different angles, the torque will be the greatest when the force is perpendicular to the distance from the rotation axis to the point of axis here. Okay, torque decreases when the force is no longer perpendicular, and then torque is 0 when force is parallel to r. Okay, yeah, so the greater the distance pula, the greater the value of torque. Okay, so maksudnya bila the value of torque is greater, it is much more easier to rotate an object. So equilibrium of a rigid body pula. So equilibrium of a rigid body, there are two conditions for the equilibrium of forces. So what are the conditions? The conditions are the vector sum of all forces on a rigid body must be 0. Secondly, it has to have the vector sum of all external torque must be 0 juga. Kenapa ni macam ada something wrong. The vector sum of all external torque must be 0. Tu dia adalah tu. Okay, so the conditions for the equilibrium of a uniform rigid body, the net force acting on the body is 0. So x and y component ni mesti 0, dia tidak movement. Secondly, the net torque about any point of the body is 0. So total summation of torque equal to 0. So untuk this type of questions, there are a strategy where first you have to draw a free body diagram and then pick any rotation point and label distance, which is r, and then always try to choose the point where the most unknown forces passes through that rotation axis. Apply this and then choose a convenient x and y axis and resolve the forces, and lastly apply this and then solve the equations in 3 and 5 to determine the unknowns. Okay, example number 2. So a floodlight of mass 20 kilogram, this is the floodlight. It is in a park supported at the end of a 10 kilogram uniform horizontal beam that is hinged to a pole. So a cable at an angle 30 degree with the beam helps support the light. So that is the cable here. So we have to sketch a free body diagram of the beam, and lastly we have to determine the tension in the cable and the force exerted on the beam by the pole. So to draw the free body diagram, instead of it being represented by a dot, for this chapter we will be drawing it as the beam itself. Okay, and then now for the weight of this beam, it will be at the center because it has it has been mentioned that it is a uniform horizontal beam. So any uniform horizontal beam, dia punya weight will be at the center because that is where the center of gravity untuk the beam. Okay, and then we have the weight of the floodlight itself, and then we have a term where we call it as a shear force. So this is basically a reaction force from the due to the hinging of this beam and pole. Is that even a word, hinging? Tapi okay lah, there is a shear force due to this interaction here. Okay, so that ada satu lagi. Lastly we have the tension, which is at an angle of 30 degree lah. Okay, so this is the angle. So let's just label them. This is 30 degree, this is the tension, this is the floodlight, and this is the beam weight, and lastly we have shear force. Okay, so for the shear force, we do not know anything about the angle, so nanti kamu akan tengok lah macam mana cara jawab. And then since this is a rotational motion where we are going to be applying torque into the equation, I would also label the distance from a rotation point. Okay, so basically this point here is where I designated my rotation point. Okay, so this is my rotation point, so I'll just label it as O lah. Okay, so rotation point tu nanti lepas ni baru kamu dapat faham, ataupun rotation axis lah nama dia. Okay, but everything is based from this reference line lah, the distance. Okay, so this is a distance, this is the beam, where the beam is just L lah, sebab kita tidak ada punya value kan. This is L as well. Sorry, not L. This is half of the L. Okay, itu adalah the free body diagram. Next, let's solve for the tension in the cable. So for this, we are gonna be applying both the X and Y component as well as the torque. So I would suggest start by drawing a table, but if you don't want to draw a table, it's up to you. Just don't make any careless mistakes lah. So this is force, this is X component, this is Y component, this is torque. Okay, so these are your forces. This is your X component, Y component, and this is your torque, where torque is equal to Fr sine theta. Ataupun it can also be written as, it should be another color. I don't really have another, okay, this one boleh lah. Fd, where D is the perpendicular distance between the force and the rotation point. Okay, ni perpendicular distance lah. Okay, so let's start by looking at the first one, which is weight of the floodlight. So we know there is no X component for this one, so there's only Y component, which is equal to should I just calculate it directly? Yeah, lah dulu. Okay, so 29.81, so you will get 196 Newton, negative because it is pointing down. And then for the torque of this floodlight, the rotation point is here, so the force, the tendency to rotate towards this rotation point is clockwise, so it will be negative. And then the force is mfg, so mfg times the distance, which is L, since it and then it is sine 90 degree lah, the angle between the force and the R is 90 degree. Okay, so kamu akan dapat, this one is negative 196 L. Okay, macam tak muat pula ni. It's okay. Then we have for the beam. So for the beam, the X component is 0 as well. And then we have the Y component, which is negative. Can I just write down the answer? Negative 98.1 Newton. So kamu tahu je kan macam mana kira. And then for the torque, it will be negative 98. Sorry, kejap. It will be negative, tapi sekarang ni. Okay, so it will be negative because from this force here, the tendency to rotate towards this point is clockwise. So when it is clockwise, it will be negative. So sekarang ni kita akan dapat negative di sini. So negative 98.1, negative the force, and then times it with the distance r, which is this one, L over 2, and then sine 90 degree. Sebab the angle is 90 degree. Actually, ini pun boleh because kita sudah ada the perpendicular distance. The distance is perpendicular is this one. So sepatutnya macam ni je pun boleh lah tulis dia ialah angle. Okay. Okay, so yang ini kamu akan dapat negative 49.1 L. And then we have the third one, the third force, which is tension. Tambahlah satu sini nanti. So the tension is equal to x component is negative t cos 30 degree, t sine 30 degree. Why is it negative? Because this is pointing to the left, this is pointing up, so it's positive. And then for the tendency to rotate, this this tension tendency to rotate is to the anti-clockwise, so it will be positive towards this point. And then the angle between this t and r here is 30 degree. The value of r is L, so that is TL sine 30 degree. So this is just 0.5 TL. Okay, then lastly we have to consider for the shear force as well. So for the shear force, we have Sx and Sy. We are only able to label it that way lah sebab kita tidak the angle semua. And then the torque, since it is at the rotation axis, the torque will be equal to 0. Alright? Okay. So from here, we can then, since they are in equilibrium, we can let the net torque is equal to 0. So kalau kita add all of this together, we will get something like this. Plus 0.5 TL equal to 0. So the tension is 490 Newton. Okay, lepas tu kita perlu cari pula what do we need to find? The force exerted on the beam by the pole, which is the shear force. Okay, so for this question, we need to apply the total force in the x component equal to 0, where you will get this equation supaya dapat the value of shear force in the x component. Okay, so Sx is going to be equal to 424 Newton. And then do the same thing for the y component. So that is negative 196 minus 98.1 plus t sine 30 degree equal, plus Sy equal to 0. So dari sini Sy will be equal to 49.1 Newton. Okay, so dari mana saya dapat this equation? It is from our table here. So this is your x component, this is your y component, this is your torque punya component. Okay, so what you need to do here is, after drawing the free body diagram, kita perlu resolve lah benda ni so that you get this table, and then you apply the net torque equal to 0, and then both x and y component equal to 0. Macam tu. Gitu saja cara solve. Okay, and then let's continue solving this shear force, because this is only in the x and y component. We need the magnitude and direction of the shear force. So the magnitude is Sx square plus Sy square, square root, and okay lah, tulis lah. So 424 square plus 49.1 square, you will get the shear force to be equal to 427 Newton. Okay, so the direction is given by theta equal to tangent Sy over Sx So shift tangent 49.1, 424. So you will get the angle to be equal to 6.61 degree. So always remember that the angle is being measured from the horizontal axis. So basically this is your S just now, this is your SX, this is your SY. So this is your angle. This is 6.61 degree as SX, SY. Okay, all right. You can either draw this diagram or you can write down above the horizontal x-axis macam tu je. Okay, all right. So that is on example number 2.